Good morning to all. In the last class, I taught you about one of the most important problem in the bearing loads, right? In this class, I am going to teach you about one of the most important problem in the gearbox. Read the problem. Design a gearbox for a drilling machine to give speed variation between 100 and 560 rpm in 6 steps. The input shaft speed is 560 rpm. The intermediate shaft is to have 3 speeds. How we can design a gearbox? How we can design a gearbox within this speed variation? Within this speed variation with 6 steps. How you can design? How you can design means already I taught you about the design procedure for the gearbox, right? It's that same procedure only we are going to follow here. First we need to find the progression ratio. First we need to find the progression ratio. That is Rn power 1 by Z minus 1. Here already we know the minimum and maximum speed. Minimum and maximum speed, right? Input and output speed, right? That we know. So we can substitute those values here and find the value of Rn, progression value. And already we know the value of steps, number of steps. So how many steps we need? 6. So Z is equal to 6. So we can substitute those values here, and we need to find these values with 6 steps, right? We need to find these values with 6 steps. So we need to divide that speeds with the PGD data book. Okay. With the help of the data book, we need to calculate the speeds. The speed will be 100, 140, 200, 280, 400 and 560. These are the 6 steps speeds, right? Then we need to arrange the gears. For that we have formulation TA plus TB equal to TC plus TD equal to TE plus TF. This is the 6 steps. For this we need to find the speed ratio. We need to find the speed ratio. That is NB by NA equal to TA by TB. Already we know this relation already you studied in the mechanics of machines also, right? Is equal to 280 by 560. Similarly, we can find the speed ratio for C and D and E and F. C and D and E and F. Then we can find with the help of NP by NC equal to TC by TD equal to 400 by 560 for C and D gear trains. For E and F gear trains, NF by NE equal to TE by TF is equal to 560 by 560. That is equal to 1. That is equal to 1. With the help of this gear speed ratio, we need to find the value of number of teeth. Number of teeth for A, B, C, D, E, F. Right? That we need to find. But they didn't mention any one of the gear teeth. Right? So I am going to assume the minimum number of teeth of the smaller gear, that is equal to 20. That is I am going to assume. Suppose they mention a minimum number of teeth, means that we need to take. Suppose they didn't even, means we need to assume, right? For that I am going to assume that minimum number of teeth is equal to 20. That is the input gear, so TA equal to 20. That value I am going to substitute in this first equation and find the value of teeth B, number of teeth B. The value will be 40. After that, I need to find the value of number of teeth for C gear and D gear. Right? For that, we have a relation TA plus TB equal to TC plus TD. Already we know the relation TA plus TB equal to TC plus TD equal to TE plus TF. Right? In this, I am going to take first two relations. relations and equate it. Here already we know the value of TA and TB. TA and TB. Only we didn't know the value of TC and TD. That we can find with the help of speed ratio relation. Already we have the ND by NC equal to TC by TD equal to 400 by 560, right? From this I am going to make the relation between the here TC equal to 400 by 560 into TD, cross multiply the TD here, right? With the help of that I am going to substitute those values here and here solve the equation and find the value of TD. Find the value of TD first. The value will be 35 teens. After finding the TD value, I am going to substitute those values in this first relation and find the value of TC. The value will be 25. Value will be 25 teens. After finding the value of number of teeth for A, B, C, D gear, I am going to find the value of E and F gear teeth. Number of teeth for E and F. For that I am going to equate the equation. TE plus TF equal to 60. TE plus TF equal to 60. Right? Already we know the relation TE by TF equal to 1. TE by TF equal to 1. So the TE equal to TF, right? Cross multiply this, TE equal to TF, that we get, right? So I am going to substitute those values here. Instead of TE or TF, instead of TE I am going to substitute the TF value. So 2TF equal to 60. So TF, what's the value of TF? 30. So at the same value only come for the TE also. The value will be 30, right? After finding the value of number of teeth for A, B, C, D, E, F here, we need to find the value of intermediate gears. We need to find the value of intermediate gear number of teeth. Intermediate gears number of teeth. For that we need to find the speed ratio. For that intermediate gears, we need to find the speed ratio first. So I am going to consider the transmission between the intermediate gear and output shaft is equal to the TG plus TJ is equal to TA plus TJ. Right? This is the intermediate and output shafts. Right? For that I am going to find the value of speed ratio. The speed ratio value will be MH by NG equal to TG by TH equal to 100 by 280. 100 by 280. Right? This is the intermediate value. This is the intermediate value. Right? This is the intermediate value. This is the minimum value. Right? So I am going to substitute that value here. And also another speed ratio equation for J, I and J. Nj by Ni equal to Ta by Tj equal to 280 by 280. This is the output intermediate shaft, right? That value is equal to 1. That value is equal to 1, right? So here also similar thing I am going to do, right? Similar thing only I am going to do. What means? I am going to assume the minimum number of teeth. I am going to assume the minimum number of teeth of the smaller teeth. The same. What I am assumed already, what I am assumed earlier, the same value I am going to assume here also. Right? TA equal to already I assume as 20 teeth. Right? 20 teeth. Here I am going to assume TG equal to 20 teeth. Because it is the TG is the minimum number of teeth. That is the smaller teeth. That is the smaller teeth. Right? That's why I am going to assume that TG is equal to 20. TG equal to 20. 20 by TH equal to 100 by 280. From that I am going to find the value of TH. The value will be 56. The intermediate gear TH gauge gear. The intermediate gear gauge the number of teeth as 56. Number of teeth as 56. After finding the value of number of teeth for gauge gear, we need to find the value of I and J, right? How you can find? Already we know the relation, speed ratio relation. Ti by Tj equal to 1, right? So we can find directly, there's both the value will be equal because Ti by Tj equal to 1. So Ti equal to Tj, that we can say directly, right? So already we have the relation. Ti by Tj equal to 76. Ti by Tj equal to 76. So we can substitute the Ti by Tj in a relation here and find the value. The value will be 38 divided by 2, right? The value will be 38. Okay, right? These are the things we need to design here, right? In the next class, I will teach you about another one most important problem. Thank you.